Good day, students. Welcome to mathgoodserve.com. This is part 4 of our Unit 1 Algebra 2 Common Core Test Review. All right, let's take a look at question number 6. It reads, if g of x equals f of parenthesis negative x, across which axis is f of x reflected to obtain g of x? So if we have the transformational form, y equals plus or minus a times the function bx plus or minus h plus or minus k, what we're looking at is the b value, the number in front of the x inside the parentheses of the function. Okay, so that's what negative x is. So for f of x, for g of x, which is f of negative x, what we have here is b is less than 0. B is negative. So if b is negative, we have a reflection. What kind of reflection do we have? This implies a horizontal reflection. Okay? If we have a horizontal reflection, what direction is it? In the direction of what axis? This, if you reflect horizontally, you're going to go across the y-axis. Okay, so it's going to be a horizontal reflection across the y-axis. Okay, so there goes the answer to the question. All right, let's take a look at number 7. Number 7 reads, if f of negative 4 equals 13, then g, and g is the inverse of f, then g of 13 is equal to what? So if you think about the inverse, what does the inverse do? The inverse takes you from output back to the input, okay? So if this is the input right here, f takes you from negative 4 to 13, guess what the inverse of f will do? The inverse of f will accomplish the opposite. The inverse of f will take you from 13 back to the input. Okay? So following that procedure, we can think of it as f of the f inverse of 13 is going to take us back to the input, which is negative 4. Okay? So since g is the inverse of f, g of 13 is equal to the inverse of f of 13, and your answer is negative 4. Okay, so there goes your final answer. All right, so the method we used here is just the mapping method. Now we can also do this symbolically. So let's go ahead and do this algebraically using algebraic notation. So if f of negative 4 is equal to 13, if I want to find the f inverse of 13, what I'll do is I'll take the inverse of both sides. Okay, let me just title this part. This is method 2, algebraic. We're going to get the same answer. I just want to show you a different way of doing it. Now I'm going to take the inverse of f of both sides. So f inverse of the left side of my equation, let me form a new line. So I'm going to have f inverse of the left side, which is f of negative 4, equals f inverse of 13. Okay, so all I'm just doing is taking the inverse of both sides. Now take a look at the left side. How does f inverse and f interact? Well, f inverse and f are opposite functions. So what they do is cancel each other out. So f inverse and f cancel each other out. You're left with negative 4. Negative 4 is f inverse of 13. But we know that f inverse is g. Okay? So we can simply conclude by writing g of 13, which is f inverse of 13, is equal to negative 4. and there goes your final result. So if you want to use mapping in and out, that works perfectly, or algebraically, you can just take the inverse of both sides to see what the resulting inverse is evaluated at the output. All right, let's take a look at number 8. We have to graph the inverse of the function shown on the right. So this function shown on the right is a straight line, and we're basically expected to graph the inverse of this. Okay? So all you simply have to do is just just write down the steps on the side. You're going to find 2 coordinate points. Find 2 coordinate points. And after finding 2 coordinate points, you simply switch the x and the y's. Okay, switch the x and y's. Now what's happening when you switch the x and y's is that you're finding the inverse. Your input is becoming your output, and your output is becoming your input. Okay, so when you switch the x and y's, plot the points and graph your line, graph the inverse. Okay, all right, so let's go ahead and do that. First thing we're going to do, let's find 2 coordinate points that are laid perfectly on the coordinate grid. So let's pick a point right here, that point, and this point. Any 2 pair of points that give you nice integer coordinate values will suffice. Okay, so here we have 4, 1. Let's write it down, 4, 1. And then this coordinate point right here is 0, 3. Now what are we going to do? We are going to find the inverse. Okay, so for f, let's take the first point. For f, the first point of 4, 1, if we take the inverse of that, what happens? Well, it goes to, the inverse is going to contain the point 1, 4. How did that happen? We just switched the x and the y's. Okay, and then for the second coordinate 0, 3, the inverse of f must also contain the point what? Must also contain the point 3, 0. How do you accomplish that? Switch the x and the y's as indicated in step 2. Last step, plot the point 1, 4, 1, 4, and 3, 0, 3, 0 right here. Okay, and then let's go ahead and draw the line of the inverse right there. Fix it a little bit. Okay, so there goes the line of the inverse of f. Let's make it green. So the black one is f, and the green line is f inverse. Let's go ahead and label that. So this is f, and the green one is f inverse. Now, graphically, we can also confirm that our results is correct by ensuring that the inverse is a reflection of f along the line y equals x. Is that the case here? Well, let's go ahead and verify. What we're going to do is we're going to draw the line y equals x, write down the diagonal, and see if this is in fact a reflection. And it certainly is. If we reflect f along this line y equals x, what we'll notice is that we'll end up perfectly on the inverse. So this is just additional confirmation that our graph is in fact correct. Alright, so for number 9, we're going to find the inverse of the given functions. Let's start with a. So for a, we're going to switch the input with the output and the output with the input. So I'm going to call f of x, x. A times x will become the inverse of f, which is what we're going to be looking for, minus 7. Okay, let's get f inverse of x by itself. We'll add 7 to both sides. that yields 8 times the inverse of x equals x plus 7. Now we're going to go ahead and divide both sides by 8. And that leaves us with the inverse. F inverse of x equals x plus 7 over 8. And there goes your inverse. Now for question B, let's write it on the center. We have f of x equals 3 over 4x plus 5. Let's go ahead and do the switch first. We have the output becomes the input, x, and the input becomes the inverse of the output, f inverse of x plus 5. Now we're going to get f inverse of x isolated. Step 1, subtract 5 from both sides, and then we'll have f inverse of x equals, actually 3/4, f inverse of x equals x minus 5. And then to finish this off, we'll simply multiply both sides by the reciprocal of 3 over 4, which is 4/3. And then we are left with our final result, f inverse of x equals 4/3 times x minus 5. Or we could distribute the 4 to the numerator to get 4x minus 20 over 3, but this answer is equally acceptable. All right, let's take a look at problem 10. It says if f of x is 2x minus 3 and g of x is 2 over 5x plus 3, then what is f of g of 10? So there are different ways we can do this problem. Two ways. We can compose these two functions and then plug in 10, or we can evaluate the inner function at 10 and then the outer function at the result we get. Okay, we're going to be using the second approach. We're going to work our way from inside out. All right, g of x is 2 over 5 x plus 3. We're now going to find g of 10. Okay, g of 10 is 2 over 5 times 10 plus 3. Using order of operations, if we simplify this, we'll have 20 over 5 plus 3, which is 4 plus 3, and we get 7. Okay, what do we do next? What we have just found out is that the g of 10 is 7. So what we'll do next is simply plug 7 into f. Okay, so f of g of 10, what we're looking for, is equal to f of 7. The answer we got by evaluating g at 10. F of 7 is what we'll get when we plug 7 into f, which is 2x minus 3. So we have 2 times x. For f, x is 7 minus 3. 2 times 7 is 14 minus 3. Final answer is 11.